So, welcome everybody to this special event on antimicrobial resistance. Thank you all for coming, and I'm sorry there was some confusion about the starting time. I'm Joanna Haigh, and I am Director of the Science and Solutions for a Changing Planet Doctoral Training Partnership, which is a NERC-funded Natural Environment Research Council, I get all these acronyms right, project for supporting doctoral research across the remit of the environment. So I'm also chair of the Grantham Institute at Imperial College, where we support, encourage and initiate research across the whole remit of climate change and environment. And we're particularly interested in stimulating multidisciplinary research. And so the whole concept of climate change and health is something that we're really very interested in working on further. So as part of the doctoral training partnership, the students come in from a whole range of different departments, chemical engineering, maths, medicine, business, across the whole remit of the college. And one important aspect of the whole training is that they do some work as cohorts, so multidisciplinary projects. And we call these team challenges. And each year we have a new group of students, small groups of students in about 8 groups of 8, who set up a challenge. We make sure that the students all come from different areas, so it's not just a discipline-specific group. And they choose their own challenge, and then they start to work on it. So this is not a research project in as far as doing academic research. It's a research project in order of finding out what are contemporary issues that people want to know about, and how that they can help pass over some understanding about the topics. So one of the challenge teams that get established in this way this year is called Healthy People, Healthy Planet, and I think they're sitting at the front here. This is the team, and they decided on the topic of antimicrobial resistance. And so they've been doing their own studies on what it is and what it means, and I hope you're not going to ask me what it is or what to explain what it is. Oh, I was told to tell you, #AMR, is that right? Yeah, #AMR. So that one of the activities that they've initiated is this panel discussion here, which we're going to learn from people who really do know about the topic, different aspects of the topic, something of their expertise. So we're going to have short presentations from each of the 3 experts here, and then we'll open it up to questions, and I hope we'll get a good discussion going about any aspects you want to talk about. So if I can just introduce the panel. First over here is Kitty Healy. Kitty's head of antimicrobial resistance team at the Veterinary Medicines Directorate. She graduated from Bristol and worked in a small animal practice in Wales and Manchester before undertaking an epidemiology PhD at the University of Liverpool. In 2009, she joined the Veterinary Medicines Directorate's team of vets, responsible for evaluating target animal safety and efficacy data for pharmaceutical veterinary medicines in the UK. She became team leader in 2011. And in 2015, she became head of the VMD's antimicrobial resistance team, which works with stakeholders and other government departments to implement the UK 5-year antimicrobial resistance strategy. So Hitty is a government employee, and she's pointed out to me that because of the government PERDA thing, she's not allowed to talk about any policy angles going into the future. And I think Andy, who's also on our list here, is in a similar position. So you can ask about government policy, and they can talk about it in the past, but I think they're not allowed to talk about it in the future, unfortunately. Perhaps they can talk about relevant issues. I don't know. Anyway, that's that. Just to warn you. The second speaker, I think which order we're going in. We're going to do Timothy next. Yes, so that's Timothy on the end there. Timothy Rawson. He's a junior doctor, but he's taken time out of his medical training to do a PhD with the National Institute for Health Research, their Health Protection Research Unit, on the topic of healthcare-associated infections and antimicrobial resistance at Imperial College. And his research interests are around methods of enhancing antimicrobial stewardship interventions. So we've got with the animals, and we've got the people, and what are we going to do now? This is, in the middle here, is Dr. Andrew Singer, who works at the Natural Environment Research Council Centre for Ecology and Hydrology in Wallingford. His background is in soil and water science, and he got his degrees from the University of California at Riverside. And he has an interest in understanding the effects of microbial ecology and function in soil and water systems. His research leans towards the policy angle, so, for example, characterising the nature and effects of large-scale pharmaceutical use during an influenza pandemic. And his current research aims to better understand the drivers of antibiotic resistance in the environment and their implications to ecosystems and also to human health. So this is an incredibly interesting range of specialities we've got here that we can exploit. And the challenge team asked them all to think around antimicrobial resistance and how can work on AMR be used to help tackle the United Nations Sustainable Development Goals, another acronym here, SDGs. So these, if you've probably heard about them, United Nations programme to try and improve the human condition, basically, across 17 different goals, which include various aspects, one of which is climate change, another which is health, but many of which are overlapping. So the panellists have been asked, how does your work on AMR help tackle the SDGs? What is your perspective on whether responsible production and consumption of antimicrobial drugs is achievable for a healthy planet? And finally, what further research or support is needed to tackle the AMR threat and to achieve the multiple sustainability goals? So after all that introduction, I'm going to ask each of them to give a 10-minute introduction to their topic, and then we'll have some questions. Kitty.
Thank you very much. I think that mic's working. Great. Okay, well, thank you very much for the introduction, and it's really a pleasure to be here today. I've been saying to the team how much I enjoyed the questions and how they helped me to think a little bit outside the box that I've got into the habit of thinking about. So yes, I'm a vet. I work at the Veterinary Medicines Directorate, which is an executive agency of Defra, the Department for Environment, Agriculture and Rural Affairs, Environment, Food and Rural Affairs. But essentially it's Ministry of Agriculture. And I head up the AMR policy and surveillance team. So we look after AMR policy and also the surveillance programmes on antibiotic use and resistance in animals in the UK. So this is just a recap of the questions that I was asked, and I will come back to them. I'll go through them in that order, and I'll come back to them as they come up. So to start off with then, what's our work on AMR in the context of the Sustainable Development Goals? So these are the three main strategic policy documents that we work to, and from left to right they are the UK 5-year antimicrobial resistance strategy, the Global Action Plan on Antimicrobial Resistance, which is badged as WHO World Health Organization, but was produced very closely in collaboration with the Food and Agriculture Organization of the UN and the World Organization for Animal Health, the OIE. And then on the right-hand side, you have the final report by the AMR review led by Jim O'Neill, which was commissioned by the previous Prime Minister David Cameron in 2014. So that was published last year, and the government responded to it with commitments in response to the recommendations from that report, and those were published last September. So that is the framework, the policy framework within which we work. And that can be summarised by saying, and this is sort of this is certainly applicable nationally, it's also applicable internationally, and we'll get onto the international angle shortly. But we're looking at improved surveillance, and that's surveillance on use of antibiotics and resistance to antibiotics in bugs that live in animals. We're looking at reduction targets for use of antibiotics. Now, we look at reduction targets for use. It's much easier to measure use than it is to, well, we can measure resistance, but use is the thing that we have the control over, and we work from the first principle that any use of antibiotics, whether it's responsible or whether it's irresponsible, exerts a selection pressure for antibiotic-resistant bugs to flourish in a population. So we couple that with promoting good antibiotic stewardship, which is to say using the right antibiotic when it's needed, but only when it's needed, and not when something else, including an intervention like improving husbandry practice on a farm would prevent the need for antibiotic use. And that's all linked in with prevention of disease. So if you have healthy animals, then you don't have a disease to treat. So in an ideal situation, we would like prevention of disease, in other words, reduction of the need to use antibiotics, to be the way we go with this. That's through things like biosecurity, infection prevention control, in other words, good hygiene practices, good stockmanship, so farmers who know and understand their animals and pick up signs of disease early, good relationships with vets and paraprofessionals. And so, of course, that links in with training of vets and training of farmers and training of paraprofessionals, so that everybody is up to date and takes their responsibilities seriously. And responsibilities is definitely a word that's relevant here, because these antibiotics have been termed a public good, which is absolutely correct, and so it's a responsibility for everyone who is part of that chain of prescribing or use. Research to understand better how resistance emerges, how it persists, how it transmits from animal to animal, from animals to humans, from humans to animals, and through the environment, which I think I'll leave those aspects there for the moment. Promotion of a One Health approach to antimicrobial resistance, by which we really mean that whole big picture. I haven't got a diagram here. If anyone's interested, I can point you in the direction of some complicated AMR systems maps which draw out some of the interactions and potential transmission routes, but it's absolutely a multifactorial problem. And then protection of the environment, and I am not going to talk about that any further because Andrew can do that far more eloquently than me. So I went through the Sustainable Development Goals in detail, which was really interesting because I hadn't managed to set the time aside to do that properly before, to read through the whole document. And I picked out the ones that I thought were most relevant to the work that we do on AMR in animals. So you'll see I've got, I don't know whether you can see it clearly, there are two that I've put in bold and there are two that I've put in brackets, but I'll go through them in order. So I think that the ones in bold are the ones where I think there's a really clear link. So SDG 2, which deals with the need to eliminate hunger, the need for food security, so available and safe food, adequate nutrition, and sustainable agriculture. So that's absolutely linked in with needing to have functional, sustainable agriculture systems, where links in with what I was talking about, prevention of disease, rather than relying on antibiotics to solve the problem once it's there. SDG 3, healthy lives. Now this is of course relating to people, but I'm a vet, I have an interest in healthy animals too, so I think that that's definitely, there's definitely a read across there. Access to universal healthcare, of course, there's a debate that goes on about what proportion of the problem is caused by antibiotic resistance in bugs in animals. What proportion of the human clinical resistance problem is that? I mean, the straightforward answer is we don't know. But we have enough evidence to know that it is part of the wider picture. And so we have to look at this from the perspective that if we are using antibiotics in an irresponsible way in animals, then that will contribute to some as yet imperfectly defined extent to the overall risk of AMR in the ability of doctors to treat clinically affected patients, as well as vets being able to treat animals. Education, I touched on that before, I won't go into that in detail because I'm probably already overrunning. Clean water and sanitation, absolutely for healthy people, but also it's something that we're picking up on very much. We're seeing that in this country as we're looking at how can we prevent disease. Well, I heard some pig farmers saying, well, we wouldn't give our pigs water that we wouldn't drink ourselves. I mean, you need healthy animals to produce healthy food. Resilient infrastructure and sustainable industrialisation. Now, I recall from reading the SDGs that actually that wasn't tailored towards agriculture in any way, really, but I put it in there because I think that when we look at improving or increasing productivity, very often that goes hand in hand with increased intensiveness of farming, and so that obviously is something we would need to look at trying to encourage in a sustainable way. And that's linked in very much with, so SDG 12, sustainable consumption and production patterns. I think that's probably where that really links in. So if we're increasing our productivity in the agriculture sector, and I am focusing on livestock agriculture, the crops are a separate issue, but I won't bring those into my comments. So yes, making sure that any increase in intensivity is sustainable. In brackets then, sustainable use of terrestrial ecosystems, just because there are various questions, for example, how much land do you need to grow the crops to feed your animals? Again, I'm completely taking it out of context, that's not what the SDG is actually talking about, but I think it's a relevant point that comes into the whole picture. And there's, of course, that slightly controversial area around antibiotic growth promoters, which we don't do in the UK, which is banned throughout the EU, but which is a practice that does go on. So that's giving antibiotics to animals to improve the feed conversion of the food within the animals, so that you need to feed less food. So potentially, for example, if you're growing crops, that might mean you need to use less land to grow the animal feed. But of course, we do not support the use of antibiotic growth promoters in animals because we're concerned about the potential for increasing resistance. And then lastly, strengthened implementation, which I think is self-explanatory. So then what's Defra's position on international AMR work? So I'm just going to read this out. I won't do this for any of the other slides, but this comes from our government response to the Jim O'Neill review on AMR. And so hopefully you'll see how this ties in with the SDGs I've gone through. So internationally, we will continue to play a leading role with international bodies such as FAO and the World Organization for Animal Health to improve regulated access, so access under supervision of people who are adequately trained, and responsible use, so only when necessary and when nothing else will do, of veterinary antibiotics globally, taking a staged approach to support capability and infrastructure. So we're talking about having the frameworks in place, having the veterinary education in place, having the legislation and the ability to enforce the legislation in place, and improved surveillance, so that we know what the baselines are and we know whether what we're implementing, or I say we, so that in the countries, the interventions, you can measure the success or otherwise of the interventions. And in this way, including through the UNGA process, acronym UN General Assembly process, which refers to the declaration that was adopted in the UN General Assembly last year, which I'll touch on shortly, advocating towards setting targets. That's working for us in the UK, but in a way which is appropriate for each country and region. So, second question, I'll speed up. Is responsible production and consumption achievable for a healthy planet? And what I've done here is simply, I jotted down some things that I was reading when I was looking through the SDGs that are all absolutely things that are of great importance, but they're not necessarily easy to achieve at the same time. So obviously ending hunger, but then food security. So we need to produce enough food, but we need to produce it in large enough quantities, but cheaply enough and safely enough that everybody can be fed and can have access to that food. Safe drinking water and sanitation, as I say, absolutely for people, good for animals too. Cultural diversity, what happens if we come up against cultural practices which we're respecting but which could potentially undermine the actions that we want to take. I mentioned antibiotic growth promoters, intensive farming, again, potential risks there with AMR if we're looking at increasing agricultural productivity and production, particularly if you're looking at it as increasing the income. So you're not just looking at increasing productivity, you're also looking at doing that with increased profit margins. Genetic diversity of animals, I stuck that in actually because one interesting thing is that there are some people looking into whether it's possible to selectively breed resilience against disease into animals, and so perhaps that would be conflicting with that. And then universal health coverage, meeting the needs of the most vulnerable. I'm slightly straying away from my territory here, but the problem with AMR is, well, one problem with AMR is that you have a patient who may or may not, but probably, let's say, needs antibiotics, but every time you give one patient antibiotics, then you increase the risk for lots of other unknown patients, and that's, you know, human or animal or down the line. So you've got the direct need conflicting with the less tangible future risk of antibiotic resistance. So what do we need to succeed? Yeah, I skirted around the actual question, didn't I? So is it achievable? Well, I hope so. I hope so. Maybe that should form part of the discussion. What do we need to succeed? So this is where we're on this is the road we're on. So we've got, it went to a high-level meeting. AMR as a whole topic went to a high-level meeting last September at the UN General Assembly. Significance of this, there's lots of different aspects, but for me, I think It's getting the high-level political buy-in, because that's what's needed to divert resource towards the problem in organisations and countries. It's also the fact that it's brought in a follow-up mechanism for evaluating progress against the Global Action Plan, which I mentioned in my first slide, so that the momentum is maintained so that it doesn't just fall away. And also reaffirming commitment to delivering against the Global Action Plan. And it's a good document. There is a lot of concrete, well-balanced One Health action within that. We also need the what we call tripartite, the agriculture, animal health and human health organisations here to continue to work well together, to talk to each other, to make sure that what they're doing is complementary and not conflicting. And this is where, now you'll remember that in what's Defra doing on AMR? Well, I mentioned the tripartite organisations and saying that we will work with international organisations. Those are not the only international organisations we work with, and I should say that this is, I'm giving a Defra perspective, but this is far broader than Defra. So what's probably missing actually in this is a reflection that across Whitehall we work together to try and capture all of the different angles. But here, I won't go through each of these logos, but just to say that the UN one is the top left, and the others without, that you may not recognise, that don't have names. There's the World Bank in the middle at the bottom, and then the Global Health Security Agenda in the bottom right. So what do we need to succeed? Well, I think reflecting all of that, and in addition to the high-level buy-in and the support for believing that this is a problem that needs focus and tackling, I think taking these together, collaboration, coordination and communication are essential, because this is such a cross-cutting issue that it's very easy to slide into silos. I felt when I was looking at the SDGs that I was in a big silo of my own that I hadn't realised, and it's really important to keep challenging that. Really important to have dedicated resource to coordinate. Otherwise, coordination of different activities is not something that is the default position that happens when no one's really paying attention. It needs active coordination and communication between those. And then effective embedding of the One Health mindset. It doesn't come naturally to a lot of people, but we really are all interlinked, and I think that this is something which is really starting to happen. And yes, and beyond, that was just to reflect all of the new trains of thought that went off in my head with reading through the SDGs. Thank you.
Thanks very much. Thanks very much. So my name's Tim Rawson. I'm working currently as a clinical research fellow in the Health Protection Research Unit for Healthcare-Associated Infections and Antimicrobial Resistance, which is led by Professor Alison Holmes. And within the unit, we work in a really multidisciplinary team, not just of healthcare professionals, but health economics experts, mathematicians, and systems dynamics modelers, for example, to try and look at different aspects of antimicrobial resistance in terms of human health. And I thought I'd just start with this saying, why do we care? Well, actually, even today, antimicrobial resistance is a global patient safety issue. So this year, about 700,000 people will die directly because of drug-resistant infections. And in Europe alone, this probably costs us somewhere in the region of about 1.5 billion euros every year. And if we look forwards, unfortunately not to 2030 like the SDGs, but to 2050, which was, there were some estimates in the AMR report by Jim O'Neill, which suggested that up to about 10 million people a year could die directly because of drug-resistant infections. And to put that into context, at present, about 8 million people die a year because of all types of cancer bundled together. And the estimates in terms of cost to our society, where this could cumulatively cost up to about $100 trillion by the year 2050. So I think when you start to think about this in terms of the Sustainable Development Goals, you can begin to see where this might fit in and impact actually on whether or not we'll achieve some of these. But what I want to do is not just go through now a little bit about our department and some of the research we're involved in about trying to tackle AMR in terms of human medicine, but also I want to just touch at the end on actually how trying to achieve some of the Sustainable Development Goals may in fact help us in the fight against reducing the burden of antimicrobial resistance. So what do we know about antimicrobial resistance? What drives it? So we know that if we expose organisms to antibiotics, or even before we expose them to antibiotics, there is resistance in any population. But the overuse and the misuse of antibiotics in humans particularly is one of the major drivers that we can actually do something about. And to put this into context for you, in the United Kingdom, the majority of people that prescribe antibiotics, they're not infection experts. We see about 74% of all the antibiotics in the country prescribed in the community by general practitioners. And if we look in primary or secondary care at the rates of appropriateness of antibiotic prescribing, it's only somewhere in the region of 30 to 60% of all prescriptions are inappropriate in some way. About a third of those will be prescribed for too long a length of time. About a third of them will be prescribed for things that aren't actually, for example, bacterial infections. So we prescribe antibiotics when it's a viral infection. And the remaining third are things like prescribing lots of antibiotics that have the same effect on the organism, so redundancy, for example. So if we know that misuse and overuse of antibiotics is one of the leading drivers of antibiotic resistance, why can't we just prescribe less, be more restrictive? Well, I don't expect you to read this, and I think this might be one of the systems maps we spoke about. But this is a systems map which was produced by the Department of Health, and this one particularly just looks at the drivers of antibiotic resistance in only the hospital setting. And I always like to put this up because I think when you begin to look and consider antibiotic resistance in this sort of context, you begin to see just how complex it is and how probably little effect one single intervention from one single specialty is actually going to have on this global problem which crosses all disciplines. So within our department, one of the areas we like to look at is around improving behaviour change towards antibiotic use. We see that actually, you can implement guidelines, you can implement policy, but actually still there's a huge effect of culture and dynamics within different teams which influences how antibiotics are used and how antibiotics are prescribed. So for example, the role of hierarchies and senior influence on junior doctors who prescribe in secondary care. And so within our unit, led by Professor Holmes, we try and focus not just on the prescriber, but also at the organisation level and also the patient level, and try and span across not just the community, but also hospital medicine. And with the digitalisation of medicine in general now, we've moved to electronic health records, electronic prescribing, we're storing all of our routinely collected data electronically. Within our unit, we've been trying to understand how we can use technology in an efficient way to improve behaviours towards antibiotics and improve antibiotic use. And so I'll just spend 1 or 2 minutes just telling you a little bit about a project that I'm involved in. In terms of how we prescribe antibiotics at the moment in hospital, we prescribe them in a guideline-driven manner. Now, guidelines are often quite inflexible and don't allow for variation in individuals that we see in front of us at any one time. But also, when we develop tools to improve antibiotic prescribing, if you remember that the map I showed you, we only often focus on one narrow aspect of antibiotic selection. And we forget that actually there's the role of actually giving the correct dose for the patient also to maximise killing in that individual, whilst minimising harmful consequences such as the development of antibiotic resistance, but also toxicity to our patients. So the first part of the work we've been looking at is integrating those two aspects of decision support and making them more advanced and a little bit more intelligent about how we do it. And that's been looking at using things like machine learning and different types of sensing to be able to actually detect and monitor antibiotics in the individual patient in a more accurate manner, and then adjust how we deliver them in real time, or near real time anyway. But the second aspect I just wanted to tell you a little bit about in terms of when we look at integrating how we provide support to improve behaviours is actually engaging with individuals as well. And there's sort of two aspects to this. First of all, there's engaging with patients about the decisions we make. And now in the community setting, we're seeing actually that sharing that decision making, especially when it's something like a respiratory tract infection where perhaps you don't need antibiotics, that can actually significantly improve antibiotic use in the community. But also, when we've looked in hospital, we've also seen that the way that we provide information to our patients and communicate with them during infections can also have a significant impact on influencing their behaviours and attitudes actually after they've been discharged from hospital and then encounter infections or antibiotics again in the future. And so a really important part we've been focusing on in our work is actually how do we engage with patients during that infection spell to provide them with just about the right amount of information or somewhere to go to actually understand more about antibiotics and how they should be used appropriately. And very finally, I mentioned to you that actually one of the big problems we have is the fact that the majority of people that prescribe antibiotics, they're not infection experts. And although it's great to look at public engagement with antimicrobial prescribing, there's still a significant gap in awareness and actually understanding about antibiotic resistance and antibiotic prescribing with people that are actually using these tools we're developing and prescribing antibiotics. And so a lot of our work also focuses on how do we understand and monitor the impact of our interventions actually on that end user, rather than it just being developed by an expert and expected to work when we roll it out in whichever scenario we're working in. So that's a little bit about what we do locally, but what about stepping back a little bit and thinking about outside of the United Kingdom? And I just wanted to touch on this, which is sustaining the effectiveness of antibiotics versus providing appropriate access. And actually, one of the big problems we have at the moment is that in terms of access to appropriate antimicrobial therapy, a lack of access is killing more people each year at the moment than drug-resistant infections. And actually, if you look at certain estimates, if we could provide universal access to appropriate antibiotic therapy for under 5-year-olds with lower respiratory tract infections, it's estimated that actually this could have the potential to reduce mortality by about 75% in this cohort. And the second point I just wanted to pick up on here around effectiveness was actually how the Sustainable Development Goals and focusing on those could actually lead to an impact on antibiotic resistance. And two examples I just wanted to pick up on were around vaccination here. And actually, once again, estimates that if you increase the conjugate pneumococcal vaccine by sort of into a universal coverage, actually this could reduce the rates of antibiotic prescribing for patients with lower respiratory tract infections by almost 50%. And if you think about that in terms of the little bit of evidence we know about trying to reduce the exponential growth of AMR, we know that in certain situations, particularly in hospital, if you can target reducing antibiotic prescribing for a specific agent by about 10 to 15%, then in certain studies you begin to see a reversal or at least a stabilisation of that growth of antibiotic resistance. And the final point here is around water and sanitation, which is very much the same. And there was, as part of the Lancet series looking at effectiveness and access for AMR, they estimated, as well as the O'Neill report, they actually looked at the role of water and sanitation and actually suggested that actually by preventing diarrheal disease in low and middle income countries, there was a potential to reduce antibiotic prescribing by about 60% in these. And so that's very similar to the side of vaccination. And very finally, just because I know we wanted to touch on production of antibiotics as well and new antibiotics. So I think that new antibiotic class discovery is actually, it's a really important aspect that we do need to focus on. But it can't be done in isolation. And I won't go through all of these bits I put on here, but I do want to just highlight one point as well, which I think is incredibly important to consider and take away. And it's very well as developing new classes of antibiotics, but if we don't learn how to use the current therapies which we currently have available to us in a more precise and a better fashion, then actually we're probably going to make the same mistakes again when we produce a new class of antibiotic and begin to use it exponentially and see emergence of resistance very quickly. So I think this is something that's really important that we have to consider when we think about developing new antibiotics as well. What can we learn from what we already have available to us and the steps that we have made to improve prescribing of them? So very finally, just for further and future research, I think the role of, as you're going to hear probably throughout this evening, the role of One Health approach and events like this where we get to meet with people outside of our own disciplines is vital. Because as we saw, regardless of the size of impact, the role of environment and agriculture does have an impact on human health, and I'm sure human health has a similar impact on the environment and agriculture. And really working on cross-disciplinary engagement with this problem is really the next step in taking research forwards. From my perspective also, I think there is an incredibly exciting role for technology in helping us promote better prescribing and better use of antibiotics. But it has to be done in a really specific context with a really specific focus, that we don't just produce something and throw it out there and see what happens. It has to have a focus on how do we actually improve the behaviours, improve the current systems that we have available to us. And very finally, a point I just wanted to make is that also we need to move away from siloing people into prescribers, patients, policymakers. And actually, it's the role of the citizen in preventing AMR, and we all have a role to play in this, whichever way that is. And I think this will be something that will be really important going forwards also into the future. So that's me done. Thank you very much.
All right, is this working? Yeah, maybe? We'll find out. So I'm Andrew Singer, and I'm really glad the 10 minutes is not really 10 minutes. Because it would have been a very quick talk. But I'll try to make it quick anyway. So you know the questions that we've been asked. Question one is, how does my research help tackle the SDGs? What's interesting is that I've never been asked that question before, and that's a problem, because why are we funding research that isn't answering these questions? So anyway, but despite that, I could actually tick a lot of the boxes, which I will do. But I'll first tell you what the research is that I'm doing in very sort of high-level terms. The first research aim is to determine the relative importance of AMR drivers towards resistance selection in everything, so air, soil, and water. And so when I say AMR drivers, that's my catch-all phrase for everything that drives resistance. And what you may or may not know is that a lot of things drive resistance. We all know that antibiotics are, and so that's what you probably thought when you walked in the room. Biocides, they're in everything that you use on a daily basis, really. Anything that's a liquid that sits on a shelf for a while has probably a biocide in it. Metals, if it doesn't have a biocide, it probably has a metal in it. And then genes, which is a bit more complicated, but because it was supposed to be a 10-minute talk, I won't talk about it, but they are important. And there's a paper here which actually will take up probably an hour of your time, and it's summarized by this little equation which basically says everything with the same mode of action coming from a wide range of pathways are a unit of measure that we have to then assess for resistance. So basically it comes down to the mode of action and where it comes from, which is then the second research aim, is where is all this stuff coming from? And it comes from, well, it comes from everywhere, but there are some lower hanging fruit. So we have industry, your home, it comes from animal production, and it comes from crop production. And the downstream, sometimes literally, places where those lead to. So obviously our sewage goes into our rivers, and our manure and our own byproducts go onto crops eventually. And so we are exposed to it whether we know it or not. Those are some of the pathways, and Defra has a very similar, what do you call those, flow diagrams or something like that? Some plots that the Department of Health has, and it's just crazy. But so this is your short version of it, and it's mostly right. So the third aim is basically to produce something at the end of the day that someone is going to find useful. And this is the kind of document that you want to start influencing. Obviously, the next one is the one you want to influence, because this one's nearly done. But so Kitty was the first one, had already mentioned this one, but then the one step higher than that is there's a European Commission one, and we're between that. And then there's a WHO one. So they sort of talk, they must, because WHO is made of us, so we have to be talking upwards as much as they're talking down. So that's where I'm hoping to obviously influence. It does trouble me now that I think about it even more that I've never been asked to tick any of the boxes here before. But fortunately, I can tick easily 10 of them. Even the best efforts, I really couldn't tick a few of them. So I'll quickly go through the ones that I was able to tick. So it may be, this is probably the biggest stretch one, so give me a little credit here. So low and middle income countries are less able to develop and implement a holistic AMR action plan. If you look at who has developed them, actually there are a few low middle income countries that have developed them by now, but they're typically just copies of ones that we produced in other countries such as UK. And implementing it is far more difficult than copying someone else's work. So I think that's a huge challenge that Goal 1 needs to be addressing. So Goal 2 so this is how my research feeds into it, and it's obviously not direct, but it's aspirational in many ways. So determining the impact of animal feed supplements on AMR selection in animals and the dissemination of antibiotic resistance genes, so that's ARGs, in manure. Now, so this is just one probably many things that fall into Goal 2, but it was supposed to be a 10-minute talk. So that's one. You may or may not know that animal feed can have antibiotics in it, depending on what country you're in. It always does, or it never does. And then metals are in a lot of animal feed. That's a topic for another day. And there is an etc. to that, which I won't get into, but the list does go on. So animals aren't just being fed whole grain oats. Goal 3 is good health and well-being. So by minimizing the environmental reservoir of antimicrobial resistance, it helps to maintain the efficiency of existing antimicrobials. So we get more bang for our buck if we stop spreading out things that drive resistance in the environment. We get to keep them for longer. So Goal 6 is clean water and sanitation. This is probably the easiest one to tick, except if you're going to put it in terms of safe, someone's got to figure out what safe is, and that's a whole career's worth of work. And in fact, it's probably multiple careers worth of work because we keep redefining things based on things that we never were able to. So before the molecular age, we were culturing things, and so safe was whatever you cultured, and now we can sequence the heck out of anything, and we could find it to a limit of detection of the technology, and so that's where safe becomes. And then eventually we're going to be able to sequence even the things that are below the current detection limits, and so then we redefine safe based on those detection limits. So it's a technologically driven definition of safe, but eventually we get to the point where we say that's good enough. But we're nowhere near that yet. Well, depends where you are. Goal 8 is inform and drive the drive to limit the use and capture, recycle, and or replace AMR driving chemicals that are within our manufacturing path and reduce their waste. So this is basically, we use a lot of things, I might say willy-nilly, so things without any consideration for the fact that there's an alternative that may not actually induce selection downstream. So you go into any large, like Home Depot, Office Depot, what are those things? Is Home Depot, yeah. Something like that. And you buy a 20-liter jug of biocides so that you can clean your decking that has algal, the green algae all over it from a wet and dark winter. And so you blast it, and it washes off and down the drain and then into your sewage works and then into the rivers. And so we can find biocides that are about 1,000 times more concentrated than any antibiotic you could ever find in any sewage works in the UK. That's how much biocides we have, and that's just one. And there are probably 30 to 40 of them if you were to look for them. Most of us aren't looking for them, but there are a few because now we're recognizing that they're there and they induce resistance. So number 11 is inform evidence-based policies to ensure a safe and resilient city. So obviously that's job security for any scientist, at least a socially conscious one. So 12 is responsible consumption and production. So this is tough because you need to diagnose first, and then once you understand the problem, you then need to mitigate it. We have a long history in this country that has come to some degree, an end of mining metals, but other countries, they're right in the middle of it. And as I said, metals drive resistance, certain resistance. And so where you have mining or a legacy of mining, you have a lot of metals. So this needs to be done with some thought, which we've never done before. So 14 is life below the water. This is just one that I picked. Aquaculture is a huge growing industry, and they use antibiotics, maybe not so much in this country. If you want to pick on someone, Norway is the one that uses a lot, but they're the ones who actually tell us, so they're probably not as bad as other countries because they don't tell us, like Chile and Vietnam, and things like that. So, I mean, you can really do this quite irresponsibly, and so we need to be sensitive to that. 15, diagnose and mitigate the impact of AMR driving chemicals and source pathways on wildlife. This is something we don't know anything about. This is a tough one. No one has spent any time thinking about this, but it needs to be thought about. And nearly at the end, participate in the global dialogue. So it's, if we're going to do the research, we can't just hide away in Imperial College or whatever we do our research in. We have to get out there and we have to share it. So participate and publish it, make it open, make your data open. And that's a big deal for a lot of countries. In fact, there's some really interesting stories that came out during the pandemic where some countries that were having emerging strains of influenza wouldn't share the strain information, and so we couldn't develop a vaccine. So sharing data is exceptionally important in a world where you can get on a plane and move infectious agents. So, second question. You can see why I wanted more than 10 minutes. So, but this I have quite a poor answer for. So, can we do anything about consumption and production? I'm going to jump to the last one because that's the best answer I had. I got better as I was thinking about it more. But there has been something called the Davos Declaration, which is signed by 80 different companies that produce, they produce pharmaceuticals. And so they've come up with a short list of 4 things that they're signing up to do. Reduce the environmental impact from the production of antibiotics. I could just stop there and I'll let you read it in your own time. But that one's, you might think, I don't know what the problem is. There's some really good papers out there. Now, it's, in some respects, I want to tell you that there's a huge problem out there. Anywhere where there's a production facility in a country that's not ours or somewhere in Europe or America, or basically anywhere where there's environmental regulations that are enforceable, you basically get a lot of antibiotics in the rivers because it's just what happens. So there are lots of papers coming out of countries where we buy our pharmaceuticals, and what is driving it is the fact that we're becoming aware of it. Someone actually went out there, they measured the concentration of antibiotics in a river, and they said it's coming from this plant, and this plant makes antibiotics for something like the NHS. And so the chain is being connected, and we're realizing that we're impacting other people's environment, and so this is what the Davos Declaration is saying. It's saying we're going to, they're signing up to a voluntary set of ideals which they will aspire to meet. And I suppose we give them a chance to see that they do that. Some are already doing better than others, but let's just, they're not all doing very well. Let's just leave it at that. Question 3, what disciplines aside from human and vet health, I don't think anyone else got this one, need to be part of the solution? So I had lots of answers for that, so you're probably all invited. One is the need, so the question that needs answering is, obviously there's an environmental component, and so environmental scientists of the air, soil, and water, I didn't talk anything about air, but that's a whole other interesting one. Microbiologists, geneticists, bioinformaticians, chemists, ecologists, and epidemiologists. That was top of my list. I'm sure there's others. Second one is the need to understand and change human behavior. I think that's probably, that's a tough one. So you need social scientists, international development, this is a global problem, geographers, sociologists, anthropologists, psychologists, behavioral economists. So those are the people who could help you answer that question. And then there's a third one where we need novel diagnostics. So one of the problems is that we don't know what we're treating many of the times. And so if you can diagnose what it is that is causing some sort of ailment, and you could diagnose it as being a viral or bacterial, and then one step next is if it's bacterial, what bacteria, and then one step beyond that, is it resistant, and what step after that. So if you can get some diagnostics in there that answers all those questions, your antibiotic use goes way down, and your success rate in treating infections goes way up. So this is a huge one. And I'd say all of them are equally important, just to keep things nice. But actually, I couldn't prioritize one over the other, because you couldn't be successful without any of them. Need effective communication. So you could, in theory, be unsuccessful in communicating, because right now we generally are unsuccessful in communicating. But once we have a really good plan, I think it is going to be incredibly important to be able to communicate that plan and communicate it effectively on not just Twitter, but on a global scale. People who need to know this in the heart of Vietnam, who are treating their pigs with metals and antibiotics, they need to get a message appropriate to them, just like the salmon farmer aquaculture in Norway, and so everyone needs to get their tailored message, and so that's the challenge that number 2 and number 4 need to sort out, is what's the message, how does it get to the person, and I think that is it. Sorry for the rush. I knew it would be a rush.
They've agreed to take questions, so if anybody's got anything that they'd like to ask, perhaps you'd like to identify yourself first, and then we've got some lovely people with microphones who will come and help you out. There's one in the middle there, check shirt.
Thanks very much. That's a good start to what I hope will be an interesting discussion today. My name's Terry Dawson. I'm from King's College London, Department of Geography. And I work a lot in food security. And one of the things that's a big issue, obviously, is the amount of people on the planet. 7.5 billion now, expected to be 10 billion in the future. And a lot of people are talking about the only way is more intensification of food production, and one of the key things about animal production, and obviously there's a trend towards more developing countries to get a taste for meat as well, so it's increasing in places like China and India. That intensification comes along with its own increased use of sort of antibiotic drugs because of the intensive nature of animals being produced very close together, and I just wonder whether it's something that we're up against it in terms of trying to sort of win hearts and minds when the big business of food production is really looking at their financial bottom line, and I don't see intensification going away, particularly because there is going to be an increase in demand for it. So I just wondered what your thoughts are about trying to move away from perhaps that intensive production to something that's more animal friendly and perhaps will lend itself to less use of antimicrobial drug use. Anybody can take that up, please.
Yeah, very happy to. I think that's a really good point. I think the first thing I completely agree with the point you make about increased need for, increased demand for animal protein, certainly increasing human populations. I would say, though, that intensive farming does not have to be associated with increased antibiotic use. It can be, but I would say that what it gives is a controlled environment, and it is possible. I would say that if you want to really minimize your antibiotic use, then actually it goes to both ends of the spectrum. You have intensive farms in some places where there's where people go in, there are wheel dips when you go in, you shower into it, you get undressed, you shower, you wash your hair, you change your clothes, and you put on new wellies, and you change your wellies between each bit of the farm, so you really don't bring any disease in, you don't take any disease out. And those are the kinds of farms where actually you can, under the right circumstances, really reduce your antibiotic use. I think the challenge is having, well, there's a couple of challenges. One is, can that level of oversight, that level of really strict biosecurity, how realistic is it to expect that that's something that can be accomplished in, for example, low middle income countries? And the other thing, which particularly in the UK we are very concerned about, animal welfare, a lot more than perhaps in other countries, is that the kind of farming that we want to go down? I think it's one of those potential conflicts, and something that I think ultimately comes down to how we look after animals, how we can actually implement those, and also look at, as the situation develops, have those surveillance systems in place so that you can actually monitor, is use going up, is resistance going up, so that you can actually intervene at an earlier stage. And the last thing I'll say, just so I don't sort of hog the floor, is that, of course, the flip side, if you're looking at the pluses and minuses of intensive farming, is also you have a finite earth, you have a finite amount of land to use. So extensive farming is, it seems much nicer, but it takes an awful lot more land. And so if you do the sums, then you potentially run into problems there.
Anybody else? No. Another question.
This is actually linking right back into that. Oh, sorry. Hi. I'm going to try not to stray too much from the topic we were talking about today, but just linking to that, is there an argument, having large farms versus small ones, large ones potentially have the economies of scale to have some better practices, whether that's AMR friendly or not? Do you have a view? Do you see how that links in?
Whether
because small farms presumably have to do things a little bit differently.
I think if you look across the world,
less modern,
there
I
is
suppose.
An amazing diversity in farming practices, and I think it's possible to run a small farm or a big farm very well. It's possible to run a small farm or a big farm very badly. I suppose the scale is the thing. If you run a big farm very badly, then the impact and the scale is then that much magnified. I think it always comes back to people. It comes back to people, and also the evidence base, so knowing what the right actions are to take. But if whoever is in charge of looking after those animals, I remember speaking to some people who were looking at what lay behind one farmer doing so much better in his animal health and antibiotic use than one down the road, when the farms seemed pretty similar. And actually, when they went on the farm and they looked at it, it was it's what we call stockmanship, so the amount of attention that the farmer was paying to their animals, how well he knew the animals, how early he picked up the signs that something just was slightly off. So it's kind of the art and the science as well creeping in there.
Hi, I'm Chris Murray from the Grantham Institute. Just something you said about I think it was Tim said this, about the use of antimicrobials being potentially a distribution kind of issue, that if you redistributed the overuse antibiotics in some places to areas where you need it most, that could contribute to reducing the risk. I'm just wondering if does a redistribution imply reduced overall use at a global kind of level?
So I think it's always difficult when you...
Did you hear the question, everybody? Yes, sorry. Thanks.
It's okay. So I think it's difficult because when we still have a big issue talking about what actually is an appropriate prescription of an antibiotic. But in terms of the current areas, we see that actually there are large areas where we don't actually have the appropriate antibiotics available for people to even receive therapy if they do have an infection. And so it's in those regions that it's focusing on, first of all, providing access, but then also having systems in place to maintain effectiveness. So that means you also have to have some kind of system where you're actually able to make sure you're actually treating what you think you're treating, for example, and making the diagnosis. So it's very much a parallel thought that we need access to antibiotics when appropriate, but equally we also need to focus on improving the effectiveness of how we deliver them. And I think in human medicine especially, we've always focused on, we think there's an organism causing an infection, we give an antibiotic for it, for example. But actually it needs to be a lot broader than that now, and it needs to be, we provide the right antibiotic, we provide it at the right dose for that individual person, because we can give someone lots of antibiotics and it might not be the right level, it might be too low, it might be too high. And they both have consequences on, for example, the development of resistance, failures in therapy, and also toxicity. So it's really making sure we work out exactly what is effective therapy for that individual, and then make sure that it's available when it's actually required. So I think it's double, but I think the problem around defining appropriateness is no one defines it in the same way. And you could take a panel of experts anywhere, and they would probably each have a different opinion on what effectiveness of antibiotic therapy means, even within the same hospital.
Hello, Joy Watts from University of Portsmouth. I was really interested in the different talks, but Andrew, yours particularly interesting to me as an environmental microbiologist. With a lot of the intensive farming, there's often a usage of probiotics. How do you think that sort of live culture addition to intensive farming also affects horizontal gene transfer?
Is there a lot of probiotics? Well, you could. I wouldn't mind knowing more about what you know about probiotics. So I would not have an answer for you. I'd say that's a really good question. So prebiotics are when you're stimulating the microbes that are already there. Probiotics being the one, the version where you're adding bacteria that you presume have a beneficial effect in the gut. I would say there's probably not an evidence base to even rationally give it to an animal, because we can't even say that we know what we should be giving humans. There isn't a probiotic on the market that is that can stand behind a claim that it's going to make you healthier. So it may be that there is one, and I'm just presuming that it's such a new area that I would presume that it doesn't actually do what it says. Having said that, it's probably sort of a lactobacillus kind of bacillus, that kind of a microbe which lives primarily in a gut and not outside of one. And from that perspective, it's probably an innocuous waste of money. I think if they started using other bacteria that could be harmful to human or environmental health, then I would be more concerned. So if probiotics just got silly and they started using things that were potentially harmful for acquiring genes, so horizontal gene transfer, as you were saying, what you're worried about then is for them to get out in the environment and then be able to persist, whereas the lactobacillus you're not really concerned about in the soil. Good luck to them. I mean, soil is a tough place to live, even for soil organisms, and if you're a lactobacillus, you don't have a chance. So I would say the gut of any organism is already well equipped to do everything we need to worry about, and adding more bacteria is just going to be a waste of time until there will be a time when we can do probiotics in a very rational way, and I don't think we're there yet. We sort of do fecal transplants in black boxy kind of way, but they work really well. And so I bet my life on fecal transplants. I wouldn't bet a penny on a probiotic. Yeah.
At the front here.
Hi there, Hiral Shah, Imperial College. We've helped organise the panel discussion, but the question I had was regarding a commentary which came out in Nature a couple of days ago, which talked about language and antimicrobial resistance and the fact that antimicrobial resistance itself as a word or hashtag or whatever you want to call it may not be correct, and we should really be calling it drug-resistant infections instead. I just wanted to hear from the three different areas of, do you think that's appropriate, or should we start standardizing sort of terms for antimicrobial resistance, or you know, what's the way forward actually for this? And does it matter to you?
Shall I? I think it's a really good point, and there's a few things to pull out. I'll take first, should we be calling it drug-resistant infections? The advantage of that is that it's a much easier concept. It's a much more tangible concept to get hold of. From an animal health perspective, when you're looking at what are the potential risks of drug-resistant bacteria in animals to humans, they may not necessarily be infections in animals. They may be commensal bacteria. So, for example, if you're looking at Salmonella or Campylobacter, which are both potentially transmitted in food and can cause food poisoning, they don't necessarily cause the animals any harm, certainly Campylobacter. And so drug-resistant infection is actually not an accurate description, even if they're resistant in that animal. So I think, yes, but it's not universally applicable as a replacement for antimicrobial resistance. The other thing that I would pull out, actually, I've probably used antimicrobial resistance and antibiotic resistance interchangeably, and they're not. Antibiotic resistance purely relates to resistance in bacteria to drug therapy. And actually, from an animal health perspective, that's very much where we are focusing. If you look at more broadly, and particularly in developing countries, it's much wider than that. And I won't go into more detail, except just to say that some of the figures, some of the modelling figures on the economic impact of antimicrobial resistance that Jim O'Neill's team did, used a data set of resistant organisms that included malaria and included HIV, and so that is genuinely AMR. So just to add to the complexity rather than take away from it.
Yeah, so I second all of that. Just to pick up on there, so in terms of drug-resistant infections as well, one of the issues that was picked up with, I think it was when the Wellcome initially did the work around this and suggested, a few of the members of our team in the Health Protection Research Unit actually helped with some of the preparatory work to that. And it's actually looking at when you're outward-facing and engaging with people as well. And I don't mean just patients here. In fact, if you look in healthcare in general, there's a significant proportion of healthcare professionals, physicians, who don't understand really the concept of antimicrobial resistance. So it's just trying to make things a little bit more simplistic and obvious for people to engage with as well, which is I think, the important focus. I think in the Nature paper as well, there's a focus around terminology in general and stewardship, for example. And I'm still on the fence about stewardship, but in terms of when we use it in the hospital and in terms of non-infection specialists, it often has very negative connotations, the word stewardship. It's quite restrictive in nature. And so I think that it depends on where you're looking, but there is probably a role to look at new nomenclature and trying to make it a bit more engaging and easy for people to understand what you actually mean when you come with it. Because if you look back, for example, at stewardship again, when it was first defined, it had a very clear, crisp definition about what it meant. Whereas actually now, again, much like appropriateness of therapy, there are lots of different definitions and different levels, whether it's policy, whether it's actually on the wards locally with audits, that actually it has a very different meaning. And the third point, which is slightly off topic on there that I wanted to pick up on, but I think is fairly important, is we have lots of different terminologies now and lots of different engagement around infection prevention and control, antibiotic stewardship, sepsis. And these are often quite separate. They have their own World Stewardship, World Sepsis Days, whereas actually they're all on that continuum, in my perspective anyway, of managing infections appropriately. And I think often they send conflicting messages when we have lots of different terminologies saying on one hand we should be good stewards and we should restrict our use of antibiotics, whereas on the other hand, if we consider someone as being septic, we need to start antibiotics immediately within a couple of hours. We need to give broad spectrum until we get results back. And I think when you move away from that kind of expert level where people have understanding around this towards more, for example, junior doctors or people that don't really have an interest in infection management, it becomes very conflicting and very confusing. So I think there probably is a broad issue with terminology that we use that needs simplifying, but I don't have an answer to what is appropriate in terms of to go.
I'm glad you both went first, because I didn't know what I thought either. But having heard what you said, I actually think that I'll defer back to bullet point 2 and 4 on my last slide, which said that we need a lot of people to join this discussion, and some of them are going to say that some words are better for some audiences than others. Some may disagree, and they'll say, actually, unifying the terminology will help us all understand that we're talking about the same thing. But I think that might be within a community to unify the terminology, but I think it probably will be shown to be incorrect to try to force everyone everyone, meaning globally, to use the same terminology, because I don't expect people to know the same things that I know, and they don't need to. So drug-resistant infections may be appropriate for some groups of people, and that might work, and that's what we want. We want something that works. And whether it's slightly inaccurate, maybe it's occasionally not really what we're talking about, well, it's the end game that matters, yeah.
Hello, thank you for the talks. I'm a student at London School of Hygiene and Tropical Medicine, One Health student, and my summer project will be interviewing healthcare professionals in Vietnam. And one of the preparation is that we've been talking so much, but one of the things that really strike me is that it's not the lack of knowledge, but it's the lack of incentive. So when we talk about sort of like short-term versus long-term, and a lot of people would sort of express that, like, for healthcare professionals, it's about fear, and it's like, well, it's better just to prescribe it anyway, because I might not see this patient again. So we'll go ahead with it. And with non-healthcare professionals, especially in Vietnam, who prescribe antibiotics, for them it's a complete, like, they're aware of like what they're doing, but it's like it's an economic factor. I just don't know how we'd ever get around that, and how we would increase incentive to, I don't know, to stop that sort of approach and that behaviour. I don't know, like, it's more of your thoughts more than a question.
I think it's a really challenging issue. I was working on a night shift a few weeks ago and got called to see someone, and it's 50-50, and what are you going to do? Are you going to leave them? No. And there are lots of different ways we're trying to approach this, but I mean, a big problem with infection management is in terms of, like we spoke about rapid diagnostics, we've not moved anywhere in almost 100 years in terms of how we detect organisms and we detect resistance. So on one hand, there's improving the turnaround time and being able to give people better information. So whether that's having rapid diagnostic tests available which work at the bedside, whether that's being able to use the data we have available to us better to provide decision support. So there's now lots of ways of trying to use all that electronic health record systems that we have to improve the accuracy of which we predict, is this an infection, yes or no? What's the most likely source of it? And provide help to healthcare professionals in that way. Then another big aspect is approaching it from a sort of a culture and team dynamics aspect as well. And because you can put the biggest, best machine learning system which gives you with so many accuracies this is an infection or not, but actually if you're in a team and your consultant doesn't trust it or doesn't think it's still going to get prescribed. So there's a number of different ways you have to really approach it. And I think it starts by understanding the local environment and what are the actual drivers of prescribing, and how can you then put interventions into a workflow. So I think it's very dependent not just on this country, but actually even the team that you're working with. And I think you have to be careful about individualising things too much. There has to be some way of making it context specific for that local environment, whether that's a hospital, a ward, a person. And I think that's the only way, but it's really challenging.
Thank you. Can I add to that? I really agree with what you say. I think understanding what the drivers are key to understanding what the right interventions are, and that is going to be different between different countries, between different species, for example, on the veterinary side, and I think that it's I can't remember what I was going to say now. No, it'll come back to me. I'll tell you when it does.
There's another layer to the answer that you're looking for is just because they get a prescription or they get a drug to take, it doesn't mean it is what they thought it was, because there's a counterfeit drug problem. And no one knows whether they're getting what they think. And that works for humans as well as animals. And borders are sometimes just an inconvenience. And so you may have rules in one country and it's irrelevant because they just sort of cross borders and it's in a bag with a color code or whatever it is, and they don't know it from anything else, and they mix it with some food and they feed it, and you don't know what you're doing anymore. And so obviously this country sorted the problem out. You can't buy antibiotics at all, pretty much. And so internet purchasing of antibiotics is not legal, and there's prescription only for animals and humans. So it is possible, but it requires, a societal infrastructure that a lot of countries don't yet have. And so I think what you're getting the picture is there's lots of ways to crack a nut, and there's lots of ways to build up sort of infrastructure to get to the point where you can enforce what is best practice. But until you get there, people are just going to find ways of getting around because there's a perception problem. So I keep coming back to the social part, the behavior. I think, okay, I'm going to go out on a limb and say the behavior part is the biggest challenge. If you can get people to behave differently because they understand the problem in a way that they didn't before, then I think the problem could sort itself. Because of the counterfeit drugs. People are buying them, which they wouldn't need if they were well informed, or if they did need, they would have an industry that ensured that it was what they thought it was. It goes down the road of conversation, but it's had a good start.
And I've remembered what I'd previously forgotten, and that was just to return, and it really builds on what you're saying, Andrew. It comes back to if you can get a big problem like AMR, the high level buy-in, such as at the UN General Assembly, where actually you really did see a change in the messages that were coming out of multilateral organisations that had previously just been a bit low key, and they actually started coming out and saying, if you can get that, then it filters down to say head of state level, filters down, and you really get when people get the message that the people in charge, wherever that influence may be, are taking it seriously, that is where I think you start to see the triggers for culture change, behavioural change. So, to use an unrelated example, drink driving. Drink driving is no longer socially acceptable, whereas it once was. So if you can get a situation where it is no longer professionally, culturally acceptable for a vet, for example, to just dispense antibiotics without checking, then that's what you're aiming for.
We're sort of running out of time. Just one more very quick one there. Is it quick? I don't know these people.
Really is with AMR.
I would like to know about prevention measures, such as immune system stimulants. If that is something we can talk about here, and because in terms of good practice in farms, there's some prevention measures we talk about, but in terms of the antibiotic side, we always have to talk about after, when you have to provide it, but what about prevention measures in terms of, especially, immune system stimulants.
So yeah, I can do my best to try and have a go at answering that. So I mean, in terms of prevention, I think overall there are a number of simple things to look at in terms of vaccinations. I mean, I showed the slide earlier about if you can improve coverage of vaccination, actually you can reduce the need for antibiotics exponentially in certain conditions, especially respiratory tract infections, for example. In terms of other immune stimulants, I can't say I'm familiar with a lot of them that are current practice in terms of commonly used, but I know there's a lot of research going on around inflammasome activation and things like that, which is being looked at in terms of novel ways of activating the immune system in itself to try and deal with infections. But as well, I guess as a kind of more overarching discussion, if you can improve, about some of the challenges with increasing production of foods, but actually if you can increase nutrition, increase sanitation, these are probably equally as effective and probably more important at the moment than immune stimulation in terms of preventing infections. And in terms of AMR we see in humans at the moment, we know that patients who are a lot sicker, who are malnourished, for example, often are a lot more risk of getting more severe infections from certain resistant organisms which perhaps aren't as virulent. And so someone like me perhaps wouldn't be quite as affected by and be able to deal with. And I guess on another aspect of that, part of actually using antibiotics better is to understand the impact of the immune system in people who have infections as well. So at the moment, when we look at therapy and giving antibiotics, for example, we only really ever consider, most, if we know what the organism is and we know how much antibiotic we need to kill it, we can consider that. We can also consider the amount of drug in someone's circulation. But one thing that's actually really missing is actually just an understanding of how the immune system is different in each individual and how that influences clearance of an antibiotic. So that's a lot of work that's going on at the moment with a lot of the pharmacokinetic, pharmacodynamic people looking at antibiotic dosing, is actually how do you incorporate an understanding of actually how much the immune system plays in clearance of that bacteria in individual infections, and can you tailor the amount of antibiotic you therefore give based on that as well. So I know I've gone around the houses a little bit there, but I think that's...
I'm sorry to have to stop. This is a fascinating discussion and a number of different angles. I think we're getting a sort of picture that things can be done in terms of behaviour and in terms of global action. And perhaps all of us should be doing things. I won't be washing my decking with plastic stuff. I'll probably eat a bit less meat. I won't argue with my doctor about diagnoses. But anyway, I think we're all thinking about what we should do in the future. So I'd like to say thank you very much to our speakers and invite you all to a small reception which is outside, and perhaps you can pin them down with a few more questions out there. Thank you very much.